Hey, today we are going to solve LeetCode problem number 36, valid Sudoku. If you don't know what Sudoku is, I'll leave a comment in the description. Here, basically, we need to determine whether this given 9 by 9 metric follows these three rules or not. The rules are simple. Each row must contain 1 to 9 digits without repetition. Each column must contain 1 to 9 digits without repetition. And each 3 by 3 sub box, this is a sub box. Another sub box is this. Similarly, we have 9 sub boxes. Each sub box must contain 1 to 9 digits without repetition. In this case, we don't need to check for solvability. We only need to check whether the given grid follows these rules or not. We need to only validate for filled cells. When I hear the word without repetition, the first thing that comes to my mind is hash set. Hash set is a data structure that has the property that each element in it should be unique, and it gives us O1 operation of insertion and O1 operation of checking whether an element exists in that data structure or not. So here, for determining if any digit has repeated or not, we can use hash set. We need to determine if there is any repetition in each row, if there is any repetition in each column, or is there any repetition in each of the boxes. Overall, we will need around 9 plus 9 plus 9, 27 hash sets. In each of these hash sets, we will keep on adding elements that correspond to their respective hash sets. For example, one hash set would represent this row. We will add 5, 3, and 7 to it. Another hash set will represent this row. We will add 6, 1, 9, 5 to it. We will iterate through all these elements and add them into their row or column or box hash sets. Let's take an example of an invalidity. If we are iterating through this row, the hash set for this row will have 9. We will put 8 in it. Since 8 does not exist, we will keep on iterating and reach this 8. Once we reach this 8, we determine that 8 is already present in the hash set. Hence, it breaks the first rule of Sudoku validity. In this case, we return false and break early from the algorithm. The last question that we need to answer here is, how do we determine which element goes to which box hash set? We will have to represent each box using a unique index. If you consider each box as a cell, this is a 3 by 3 metric, which means that this is 0 by 0, this is 0, 1, and this is 0, 2. Now, how do we reach this programmatically? So if we divide this by 3, we get 0. If we divide this by 3, we get 1. If we divide these by 3, we get 2. Similarly, here, if we divide these by 3, we get 0. Here we get 1, and here we get 2. So if we are talking about this cell, which is 4, 7, we need to figure out which box that it programmatically belongs to. So we divide this by 3, this becomes 1. We divide this by 3, this becomes 2. So it belongs to 1, 2 cell. We talked about having 27 hash sets. Is it possible to combine these 27 hash sets into one hash set? How would we differentiate between row elements, column elements, and box elements? We can do it by adding a prefix. For example, when we are adding 5, the indexes are 0 and 0. So we will add 0th row element 5, 0th column element 5 in the hash set, and then we will add its 0, 0. So the box is 0, 0, B5. Similarly, when you add this element, the row is 4, the column is 5, so you will add 4, R3, 5, C3, and then the box is, you divide each of them by 3, so this is 1, this is 1, so you add 1, 1, B3. If we get a hit while adding this, you see that it already exists in the hash set, you immediately return false. If not, you continue to add it. Now that we understand the complete solution, let's quickly put it into code. So the first thing that we do is create a hash set. The next thing we do is iterate through the entire grid. Okay, now that we have the double for loop laid out, the first thing we want to do is check for if the board has a number or is it an empty cell. So we check for board X and Y. Since this is a char input, we will just do not equal to dot. So we only want to proceed if it's not equal to dot. So first we will do handle rows, second we will handle column, third we will handle the box. Okay, so for row, let's put let's first create the string that we want to put. R is equals to, first X is the element, then we add R to it, then we add the board of X and Y. First thing that we do is check if this exists in the hash set. If it does contain R, we return false because our condition has been broken. If it does not contain R, then we add R to the hash set. We do the same thing for column. And we do the same thing for box. In box, we get the new indexes, which represents a box, by dividing X and Y by 3. So this is our entire code. Pretty simple double for loop. Quickly looking at the time complexity, the double for loop is running 9 squared times. So 9 into 9, which is 81, which is O of 1. Now let's see if there are any operations more than O of 1 inside the for loop. There is contains, which happens in O of 1, and then there is add, which also happens in O of 1. So the total time complexity of the algorithm is O of 1. Like if you want to keep n as a variable, and in this case which it is 9, in that case the time complexity turns out to be n squared. We have to do return true because there is no rules broken.